Good morning, Geometry iPad Initiative students. This is Mr. Lane coming again at you from OHS High School. This is section 6.5, Conditions for Special Parallelograms. So in this section we're going to be using some of the same properties that we've been learning over the last few sections. But this time we're going to show that's a parallelogram in order to show that it's a rectangle, rhombus, or square. So make sure you get the title in your notes. Make sure you get number 5. You can read through the objective and why on your own. And we're going to get rolling here. The first conditions are for a rectangle. It's 6.5-1 is if one angle of a parallelogram is a right angle, then the parallelogram is a rectangle. So there's a couple things must have for this one. Number one, we got to have that's a parallelogram. So we might have opposite sides are congruent, or opposite pairs of angles are congruent. You've got to have something that's going to show that it's a parallelogram before we can use this. After that, as long as we have one right angle anywhere, any one of those right angles would prove that it would be a rectangle from there. Alright, the second one here is that the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So we all know what the diagonals are. So again, we got to have that it's a parallelogram, and then if the diagonals are congruent, then it would be a rectangle. So let's move on here. Alright, this says that a manufacturer builds a mold for a desktop so that segment AB, that should be a congruent sign right there, not showing up quite right, is congruent to segment CE or CD, and segment BC is congruent to segment DA, and that the measure of angle ABC is 90 degrees. Why must the ABC D be a rectangle? So we've marked the 90-degree angle in here. We've got let's see, segment AB is right here, is congruent to segment right there. We've got BC is congruent to segment DA. So we've got opposite pairs of sides congruent. That's going to make it a parallelogram. If it is a parallelogram, then as long as we have one right angle, that was the theorem 6.5-1, is going to give us that it is a rectangle. So pretty short little problem there. Regular geometry students would be doing a couple of problems over that. iPad, yours should be up and running already. Alright, conditions for rhombuses. If one pair of consecutive sides of a parallelogram are congruent, then the parallelogram is a rhombus. So consecutive sides, remember consecutive doors would be right next to each other, or doors right next to each other. So sides that are touching one another share a vertice. If those two would be congruent, then as long as it's a parallelogram, we would know that it was a rhombus. So we gotta have again that it's a parallelogram first, and then if we have that condition where the sides, consecutive sides, are congruent, we could state that it is a rhombus. Alright, if the diagonals of a parallelogram are perpendicular, then it is a rhombus. So again, must have that is a parallelogram first. If it's not a parallelogram, we cannot use this theorem. So if we draw in the diagonals, they happen to intersect at 90 degrees. If we know that this is a parallelogram, then that would have to be a rhombus. Alright, the diagonals of a parallelogram bisect a pair of opposite angles, then the parallelogram would be a rhombus. So again, a parallelogram, and now we're just going to bisect the opposite, or a pair, which just means that we just need one. So if it bisects the opposite angles, then it's going to make it a rhombus. I think we've got a couple of quick problems here for examples. It says determine if the conclusion is valid. If not, tell what additional information is needed to make it valid. So we're just going to mark it as we go along here. EF is congruent to EG, and we have that EG is perpendicular to FH. So they conclude that this shape is a rhombus. Well, we would have two different theorems that we could use there, but the thing that we're missing here is that this would be a parallelogram. If it's not a parallelogram, we can't use either one of those theorems. So on this one, I'd have to say invalid. We've got to have that EFGH is a parallelogram before we can state that it's a rhombus by either one of these theorems. Alright, let's see, this next one here, it says that Let me erase the old markings, and we'll just put some new markings here. It says that EB is congruent to BG, and FB is congruent to BH, and it also gives us that EG is congruent to FH, and that also triangle EBF right here would be congruent to triangle let's see, EBH, this one right down here. Well, if the triangles are congruent, this looks like it would be a linear pair here, so actually that's going to give us some 90-degree angles. Don't know if that would help us out or not, but alright. So first off, the diagonals are bisecting each other, so that's going to make this a parallelogram. That's way back in 6.3-5 maybe. But anyways, if the diagonals bisect each other, that's going to make it a parallelogram. If these two triangles are congruent, then this angle and this angle would be corresponding parts to match up. So that would make this diagonal bisect this angle, which would make it a rhombus, and then the diagonals are congruent to each other would make it a rectangle. So if it's a rhombus and a rectangle, then it's going to be a square. So actually this one is a valid argument. Alright, here would be the regular geometry classes problems. We're going to move on here. Alright, it says use the diagonals to determine whether a parallelogram with the given vertices is a rectangle, rhombus, or a square. Give all the names that would apply. Okay, so we've got already that it's a parallelogram, so we don't have to worry about that fact to use any of these theorems. So we've probably got to worry about the distance of the diagonals to see if they're the same, see if they're congruent, and we've got to worry about the slopes to see if they are perpendicular or not. So the first thing we're going to do is go ahead and plot the first set of points here, which is -1, 1, 2, 3, 4. Put that point down. Then I'm going to go 2, 6, 1, 2, 3, 4, 5, 6. Then we've got 4, 3, right there we go, and then 1, 1. Perfect. Alright, so actually we could probably look at this picture and kind of tell what quadrilateral we're dealing with, but we want to show it, so we're going to do a little bit of work on it. We're going to put the diagonals in across here. We're going to count first. We're just going to take care of the easy part, the little rise over run here. So I'm going to count up 1, 2, 3, 4, 5, and over 1. So this one's diagonal has a slope of 5. This one here we go down 1 and over 1, 2, 3, 4, 5. So this one has a slope of -1/5 because it's slanting downward. So those two would multiply to give me -1, so they're opposite reciprocals of each other. So that's going to make that a 90-degree angle, which is going to give me that this would be a rhombus. Now I want to check to see if the diagonals are the same length. So I've got to, let's see, this one was P here, 2, 6 would be Q, this was R, and this was S. So I've got to find the distance between SQ and see if it's the same between PR. So PR is what I'm going to start with. Distance formula is a square root. A couple of parentheses in here with some squareds, get it nice and set up for us. Now I'm going to plug in my y2 minus my y1, then my x2 minus my x1. I'm just going to change to a plus there. So 3 minus 4 is a -1. We're going to square that. Plus 5 squared would be 25. Plus 1 would be radical 26. And we're going to leave it like that because all we have to do is compare it to see if it's the same length as PR. Or QS, actually. Alright, so we've got to check this one out now. So I'm going to come right over here and work using the same exact formula. I'm just going to go ahead and set it up with some parentheses and some squareds. Then we're going to have 1 minus 6 minus 2. So I've got negative 1 squared would be 1. And I've got a negative 5 squared, which would be 25. So notice that I get radical 26, which is going to give me that it is that both the diagonals are congruent since they're the same length. So that's going to make it a rectangle. So if it's a rectangle and a rhombus, then it is going to be a square also. So if the distances match up, it's going to make it a rectangle. If they're opposite reciprocals in slope, that's going to make it a rhombus. If it's both, then it's going to be a square. Okay. If only the slopes matched up or were opposite reciprocals, that would only make it a rhombus. If the diagonals came out to be different lengths, then it wouldn't be a rectangle and it wouldn't be a square. So it must be a rectangle, must be a rhombus before it's a square. Alright, I think that's going to wrap us up. So this is Mr. Lane signing off from OHS High School. Have a wonderful day.